Hello class, today we are on day 4 of our book, The Sun. We can find the sun in our Google Classroom. If you look under Classroom Resources, you'll click on the part that says Our Classroom. This is going to open up to a picture of our classroom, and you're going to find this book on the middle shelf, sort of towards the middle of the middle shelf actually. When you click on that, it'll open up some links for you, and you're going to follow the links until you get to day 4. So as usual with day 4, I would like you to read aloud with me as we read through this section. Our vocabulary word today that we'll be keeping an eye out for is sunspot. Sunspots are a type of storm. So kind of like a tornado is also a storm, but different than a sunspot. The characteristics of sunspots are great releases of energy that happen in cycles, and they might be caused by magnetic currents. So let's go ahead and look for that word in the book as we read along. We're going to start right here with where it says the sun. The sun is never at rest. Sometimes giant storms called sunspots erupt on the surface. Look at that, we found our word already. So let's see what we can find out about this sunspot. These storms look like dark spots or blotches. The line of sunspots in the lower part of this photograph is a storm 100,000 miles across, 12 times wider than Earth. Let's take a peek at those. So this is in the lower part of the photograph, so we need to go down and find the photograph. And I'm going to have to infer that this possibly here are those sunspots, because I see a line of them there. Let's go back up and continue reading. Sunspots send powerful streams of electrical energy into space. The energy released in 1 hour by this one storm is equal to all of the electrical power that probably will be used in the United States over the next million years. The numbers of sunspots change over an 11-year period called the sunspot cycle. During a year when the sun is quiet, large sunspots appear very rarely. During a year when the sun is active, as many as 100 large sunspots appear. The next peak in the sunspot cycle should occur about 1991. Let's go ahead down to the next part of the text. What causes sunspots? Scientists are not exactly sure. They do know that the sun is like a giant magnet with north and south magnetic poles. Scientists think that sunspots occur when powerful magnetic storms break out on the sun's surface and prevent some heat and light from escaping. That's why the spots are darker than their surroundings. This photo shows two views of the same sunspot activity. The picture on the bottom is called a magnetogram. It shows that each pair of sunspots has both a north and south pole. A magnetic force over 1,000 times stronger than normal runs between them and stretches in a loop up into the sun's atmosphere. So let's go back up and check that out. Again, they said that this picture is the same as this picture. They've also said that each sunspot has a north and a south pole. So I can see the sunspots here, and I would have to infer by the colors that one of those colors in the sunspot must be a north pole, and then the other color must be a south pole. But I don't really know which one is which. So again, this is the sun without showing that magnetic activity going on. We can see the sunspots marked out. And then this is a picture with that magnetic activity going on, and we can see those 3 sunspots. Looks like they have different colors there. Let's go back down to where we left off. The magnetic forces erupting out of sunspots sometimes carry hot gases with them. These flaming streams of gas are called prominences. Traveling at speeds up to 200 miles per second, prominences arch up through the sun's atmosphere. Prominences. And we can see those. You see these kind of loops right here? These are prominences. And then you see kind of a couple of smaller ones on the edge over here. And that's what they're calling a prominence. It says some prominences fly off into space. So that's one thing that they can do, fly off into space. But most loop back to the sun. So that's the other thing they can do, is loop back to the sun. We can see those looping here in this picture. Many prominences are over 100,000 miles long and 3,000 miles thick, yet they can rise and fall in just a few hours. Other prominences last for days or even weeks. This photograph shows the magnetic loops that carry the hot gases of prominences. So there's that picture again. Sometimes the magnetic forces in a large sunspot are released in fiery explosions called flares. Flares last for only a few minutes, yet can have the power of 10 million hydrogen bombs. These violent explosions send out waves of intense heat, light, and radiation. When this radiation hits Earth a few hours later, it can black out communications and cause the magnetic compasses on airplanes and ships to spin wildly for a short time. That sounds scary, doesn't it? There's one of those flares. Flares also send out great numbers of tiny particles out into space. Some of these particles reach Earth and become trapped in Earth's magnetic field near the North and South poles. As these particles come down through our atmosphere, they make the air glow in shimmering, multicolored curtains of light called auroras. In the north, this is called the aurora borealis, or northern lights. In the south, it is called the aurora australis, or southern lights. The sun is all important to life on Earth. Our weather and climate depend upon the sun. Green plants need sunlight to grow. Animals eat plants for food, and we need plants and animals to live. Even the fuels we use, such as coal, oil, and gas, are the remains of once living things. Without the sun, there would be no heat, no light, no clouds, no rain, no living thing on Earth. And that is the end of our book called The Sun. And down here, you're going to notice that there's some other books that are in the nonfiction category that you might look into if you're interested in nonfiction. And a few of those are by Seymour Simon, which is the author of this book. So he's written a book on Saturn, he's written a book on stars, and I'm sure if you looked up his name, you'd find several other ones. So at this point, you have two things to do. You do need to finish your work that was assigned for this section. And then I would also like you to go into your AR and take the AR quiz for this book. Once you've done those two things, you'll be done, and you can turn those in.